In this video, we will be discussing section 14.1, which begins on page 908 of your textbook. We will be graphing sine and cosine functions in this video, and in the next video, we will be graphing tangent functions. So let's go ahead and start off with the basic graphs. Alright, so they are kind of wavy looking functions here. The top graph is that of sine of x and the bottom is cosine of x. So if I were to ask you to draw out the graph of y equals sine of x here, well, what you would initially do is you would have to make your markings along the horizontal and the vertical axis. So for just y equals sine of x, you're going to want to put a point at 0, 0, and then mark each of your horizontal lines by a distance of pi over 2. So adding another pi over 2, you get pi, 3 pi over 2, 4 pi over 2 is 2 pi, and then your horizontal axis, you're going to mark with a 1 and a negative 1. Alright, so when you do that for sine, you start at 0, 0, and then you go up, come back down, go down, and then back up. Alright, and this is, connected by a nice smooth curve, and then once you pass that, you are starting to repeat. Alright, you're starting to repeat these cycles. So however long it takes you to, meet back at a certain point and start that repetition, that is called a period. Alright, so for sine and cosine, a period is the length of 2 pi. Alright, and why does 2 pi sound right? That means, when we used our unit circle, 2 pi meant that, you were completing a circle. You were completing 360 degrees. So there is a relationship between these functions and our lovely unit circle. So keep in mind, if you were to graph these on a graphing calculator and you go into the y equals, you need to first make sure that you go into the mode and you arrow down and press enter and get it into degrees first. So I can type in the sine of x, close it out, press graph, and that's what the sine of x looks like. Alright, so right in the center is your origin, and then notice it doesn't have as smooth of a curve as ours, but if you think about it, that pi over 2 value is about 3 divided by 2, so it should be around 1.5. Alright, and that's where the first peak is. So keep in mind it's going to look a little different on a calculator than it does on here. So you need to know the points to graph initially. Now for the cosine, instead of starting at 0, 0, we are actually taking the sine function and we are just shifting it over pi over 2. So instead of starting at 0, 0, we kind of think about it, starting going up and then coming back down. Alright, so if we still look at it starting at the horizontal axis, starting at the vertical axis, at 0, it will go down and then it will come back up and start to repeat after 2 pi. So the period is still 2 pi. And to discuss what the amplitude here is, that is A. That is how high, alright? It's going to be an absolute value, how high the wave does go. And the range, of course, over here on the left tells you how high and how low it can go. So I do have a minimum and a maximum, alright? So the minimum here is in green, max is in blue, and that gives you your range. And your domain, it does keep going left and right forever. Alright, so that's just kind of how to set it up. Very quickly drawing it out. So sine, I start 0, 0, come back down, go through the axis, This is pi over 2, pi, 3 pi over 2, and 2 pi. And then cosine, I start up top, go down, and then come back up. It still is curved, alright, and that's what it looks like. So, some characteristics here. The domain is all real numbers. You can plug in anything. This is for sine and cosine. Alright, not for tangent. It will be different for tangent. The range is between -1 and 1. So no matter what degree you plug in, no matter what radian you plug in, you're always going to get numbers between -1 and 1. The amplitude. What the amplitude is half the difference between the maximum and minimum. So you take max minus the min, and you chop that in half. Alright, and if I look back at my picture here, that's exactly what it is. I'm taking this range, this distance, and I'm chopping it in half. And the reason why they do that is this can be shifted up or down. Alright, and then a period. So what it means when a function is periodic, it means it repeats. And as you can see, it definitely repeats after a while. It keeps going left and right here. So it is periodic. So the shortest repeating portion of the graph is called a cycle. So you might hear me say the word cycle, or you also might hear me refer to how long it takes for each cycle to repeat. That horizontal length is called the period. Alright, and here for these two, the way they currently are, just plain sine of x and cosine of x, is 2 pi. So the x-intercepts for sine occur at these x values, and the x-intercepts for cosine occur at these values. Notice that they are not the exact same because they are shifted. Alright, so going back to my original, this y equals a cosine of bx and y equals a sine of bx. When I input these values a and b, that's going to change where this graph is, and that's going to change a little bit of what this graph looks like. So feel free to experiment with your calculator and add in a 2x. Alright, you could arrow down to y2 and do sine of 2x and see what that looks like instead. Alright, and kind of studying what happens to the graph. You can always use Desmos. So my next slide here talks about how to actually take these a's and b's and calculate your amplitude and your period. So these are two formulas, two short formulas. A, whether it is out in front for whether it is out in front for sine or cosine, A determines your amplitude. That should be easy to remember because A and A for amplitude. So you take that absolute value because we are talking about a distance here. And they're supposed to be non-zero real numbers. And then for a period, what I do is I actually take 2 pi and I divide it by that b. Alright, so in order to graph these key points, my x-intercepts and my max and mins, just like I did when I was sketching out these general examples, I use these values to figure out what my max and mins are and what these values are that I need to mark on my horizontal axis. So one of the things that I can point out to you is this period. That's how long it takes to repeat. So if you chop that into fourths, so you divide it by 4, that is what you need to be marking on your x-axis here. Alright, to get these nice points. And then keeping in mind, your sine is going to start at the origin, and your cosine is going to just be shifted over one piece to the left here, and is going to typically start at 0, 1, or in this case it's going to be 0, a for the amplitude. So with all of this being said, let's just look at some examples. Graph 4 times the sine of x, and y equals cosine 4x. So notice these 4's are in different places. Alright, the amplitude here for part A is 4. Alright, so that means my graph is going to be a little bit taller, and then the period is still 2 pi. So we figure out, these important points that we have to graph, and my max and mins, which this stuff, actually drawing it out easier might be easier rather than computing all of this right off the bat. I would, of course, figure out what the period is and what the amplitude is and draw from there, and then find the points. So, find the points. If my amplitude is 4 and my period's 2 pi, I'm still going to do the pi over 2. The pi, there should be a pi drawn in there, 3 pi over 2 and 2 pi. And then this just means that my amplitude hits 4 and then negative 4. And I still start at 0 and I hit those 3 x-intercepts. Alright, and then I would write the points. Part B, my amplitude is 1, so that is normal, it has not changed. However, the period is pi over 2 here instead, since we computed 2 pi over 4 using the b value. Alright, so they go through, their steps, but I would just jump straight ahead to the graph. Alright, using my amplitude is 1 and my period is pi over 2. So if I were to draw this out, I would have, pi over 2 here, and I would have divided that in 4. So that's going to be pi over 4. That's going to be pi over 8. And then this is going to be 3 pi over 8. And since this is cosine, I'm going to start at 1, dip down to negative 1, back up, and then back up again, connected by a smooth curve. So I would have created that graph first instead of finding the points and then graphing it. Alright, you can do it either way, whichever one you find easier. So here's some guided practice. Feel free to pause the video and see if you get a similar, picture. Make sure that you are labeling your x-axis here. Since it's cosine, it does not start at the origin. Sine here, my a is 5, and that affects my amplitude. And that pi for b affects my period. And notice for this one, since I divided by pi, these do not have pi in with them. The pi's canceled out. Alright, here in example 2, we are graphing where it has both and A and AB. Alright, so step 1 here. We want to go ahead and identify my amplitude as 1/2 and my period, substituting in 2 pi for B, I get my period as 1. So I can now, easily mark that 1/2 and negative 1/2, and out here is 1, chop that in half, chop that in fourths, 1/2, 3/4, and 1/4. Alright, and then since it's cosine, I start at the top, and I work my way down, and then back up. And there is my, this is not a smooth curve, alright, I need to work on my drawing skills, but that's roughly what it should look like. And then I can get the points, whereas they like to go ahead and get those points, the max and the mins, and their x-intercepts, alright, and then they create a beautiful picture, and theirs is much better than mine. Alright, so modeling with trigonometric functions. The periodic nature of trigonometric functions is useful for oscillating motions or repeating patterns. Oscillating means going back and forth, up and down, up and down, up and down. Alright, just like a piston would, a piston oscillates. Additional examples are sound waves or a pendulum or the seasons of the year. Alright, in such applications, the reciprocal of the period is called the frequency, which gives the number of cycles per unit of time. So let's go ahead and say, I have this horizontal distance, and this is what would be considered, 1 second. 1 second. It's important to, consider that distance. So we have, certain low wavelengths. So think about a deep voice versus a higher voice would have a shorter wavelength. And this applies for not only things that you can hear, which you're used to hearing frequency dealing with sound, but also frequency when you think about color as well. A purple color versus a red color and a blue color, those are on different ends of the spectrum and have different wavelengths and frequencies as well. So let's go ahead and look at some more examples. An audio test. A sound consisting of a single frequency is called a pure tone. Alright, skipping ahead here, suppose an audio meter produces a pure tone with a frequency of 2000 hertz, which is cycles per second. Alright, so hertz is a different type of unit that we haven't used before, but you might have in your integrated science class. The maximum pressure produced from a pure tone is 2 millipascals. Write and graph a sine model, so they want us to use sine, that gives the pressure as a function of time. So what that means is I'm going to have P on one side, pressure equals, I'm going to have something with sine of time. Alright, so let's go ahead and look how they end up setting it up. So I am going to have an amplitude and a B here that's going to determine my period as well. So I need to account for that. Alright, the maximum pressure is 2, so A is 2, and you can use the frequency to find B. So 1 divided by the period is going to equal the frequency, since they said they were reciprocals. Alright, so we set this up. We flip, the period and what's going on. We take the reciprocal of that. So instead of 2 pi over b, we have b over 2 pi. Another way you could set it up is 1 over 2000. 1 over the frequency equals that 2 pi over b as well, where you can cross multiply, and in either case you get 4000 pi equals b. So that is what b should equal. Substituting in those two values, you get p equals 2 times the sine of 4000 pi t. And you create this picture. Now, given, yes, there's an 8000, 2000, that's okay. We're creating, just this simple wavelength, and as long as you draw it out and you mark what that horizontal axis, goes by. So I know that here, the period is going to be 1 over 2000. So here's 1 over 2000. I chop that in half, and I get 1 over 4000. And I chop that in half again, 1 over 8000. Alright, it doesn't have to be beautiful, and then we know it goes up 1, 2, so it's going to go down 1, 2 to negative 2. Alright, and that's basically what you are using to create these points, and it is using sine, so it goes up, then it comes back down, and is connected by a nice smooth curve. Alright, theirs of course looks better. I'm just showing you how to construct it. So they get their points by computing all of these things, their mins and maxes, and their x-intercepts as well. Alright, so here's an additional guided practice. Why don't you go ahead and pause the video and see if you get matching solutions. Alright, so if you have any questions about how to set these up, what you are looking for is, a couple of questions. Is it sine or is it cosine? Where is it starting? And how high is it going? How low is it going to go? So what's my range there? What's my amplitude? And then how far is it going to go until it repeats? What's the period? And then if you take that period and chop it into those 4 pieces, what should I be marking on my horizontal axis? So those are just a couple of things we need to think about when we go to graph these sine and cosine functions. Alright, and as always, feel free to use Desmos to help you get these things set up. And then feel free to send me emails with questions. Good luck and God bless.